Today we have a 2007 Nissan Titan. And it's here today for a list of issues. Got a Christmas tree in here. We got a TPMS light on, the ABS light on, the slip light on, brake warning light on, airbag warning light flashing, and the four-wheel drive light indicating four-wheel drive when it is actually in two-wheel drive. It's only got 154,000 kilometers on it. Customers had some issues with wheel speed sensors, and apparently has changed a rear wheel bearing, if I'm not mistaken. So we're going to do a network scan on this thing and see what codes it has to offer us, help us along the way. So I haven't scanned this before, so this will be a new vehicle record. This is the first time I'm looking at this vehicle, so I have no history on it other than what I've been told by the customer. I do have the VIN number. It is an 07 Titan. Let's see if it'll auto ID with this Snap-on Veris. Nissan. Automatic ID. Should support automatic ID given the fact that it's an 07. Bluetooth connected to the vehicle, so we should be good to go. Come on, you can do it. There we go. Scan tool will scan the systems automatically in 30 seconds. Please confirm key on, engine off. So I'm going to shut the key on, engine key off. More and more manufacturers are becoming testy about scanning with the vehicle running. Well, I don't know how long this network scan is going to take, so I'm going to pause this recording and pick up when we get towards the end. So it's scanned 4 controllers so far, and I'm not liking this already. And P1564 ASCD switch voltage out of range. I have to find out what that acronym actually means. But this U1000 code, CAN communication circuit fault, I don't like that. Left front wheel speed signal erratic, left front wheel speed sensor circuit open, left rear wheel speed sensor circuit open. Now I did think he did say he had the left rear wheel bearing replaced, so maybe they damaged the speed sensor while they were working back there. Airbag crash zone sensor unit fail, low tire pressure, no data. 1708, 1709, 1710. That must be tire pressure monitors by the look of it. Probably the TPMS sensors are all dead. Pressure data error code. Battery voltage low. And I don't know if we're finished scanning yet or not, because this status bar across the top, no, not quite. 7, 8 computers, 9 computers. So it's saving the vehicle report. Let's see if there was anything in the else. Low tire pressure. Tire pressure. Lots of codes related to tire pressure. Low battery voltage. Okay, so what I notice here is lack of communication with some computers. Only 7 or 8 computers responded. Anti-lock brakes, airbag, transmission. What about the transfer case? Let's go back and let's see what controllers we have to choose from. Doesn't look like we have access to the transfer case computer, if it even has one. I wonder what module is responsible for the transfer case operation, because it's got an electric shift transfer case. Well, I'm going to peruse around in here and have a look. I'll come back when when I have figured some things out. So this is the only code stored in the transmission controller, and I don't see access to, unless the transmission controller is responsible for the transfer case. Really need to look at a network wiring diagram to see how this thing is configured. Now, just because it's not listed in the available modules to scan in this Snap-on scanner doesn't mean it doesn't exist. It could mean that they don't have access to it. What the heck is an ASCD? Overdrive cut. OD cut. ASCD cruise. I'll have to find out what that is. I was just looking to see if there was any transfer case data in this transmission data list. I don't see anything, but that's data list 1. Let's try trans data 2. No, I don't see anything to do with the transfer case. I'm going to pull up a schematic for the network. So here's the diagram in all data for the CAN communication system, and this is just an overview of the CAN communication system. So let's go down to the bottom here. We see the ECM, the automatic transmission, differential lock control unit, driver seat control, airbag, BCM, display control, data link connector 6 and 14. So this thing already complies to the CAN bus standard, transfer control unit, and intelligent power module in the engine room. And then up at the top here we have ABS actuator, steering angle sensor, instrument cluster, and front air control, whatever that is. So this definitely has a transfer case control module, but it's likely that Snap-on didn't pay for the rights to have access to it. Let's see if it's in this list. Look at that. Transfer control unit. So I'm going to try another scan tool. So we're going to try this MaxiSys. Read the VIN. So the Snap-on scanner found 8 controllers. That's the OK VIN. Yes. Gonna ask me anything else? Diagnostics. Auto scan. So we'll let this run for a few seconds and see what kind of controllers it scans. It just went through a bunch of computers and they did not respond. I've got a battery charger on it, so I know it's not low battery voltage. Normally here we'll display the scanner that responds, or the module that responds. Now it's attempting to talk to the BCM. If it doesn't respond, it'll go on and it'll still say 1 here, but I thought I saw it go through ECM and ABS already. HVAC, transmission, didn't even scan the transmission. Well, this is at about 25%, so I'll pick up when we get to the end. So the MaxiSys did scan 8 controllers as well, and pulled up codes in the engine, transmission, ABS, airbag, BCM, but it also scanned the all mode, all-wheel drive, four-wheel drive. So let's see what codes it pulled up in here. I don't believe the Veris scan tool scanned that module. So let's read these codes. Engine speed signal, CAN communication circuit, vehicle speed sensor, ABS, P1808. So I definitely don't recall seeing those on the Snap-on scanner. but we got a U1000 for a CAN bus error too. And it's going to read that module again, and it's going to still have the same codes. Okay, so I'm going to escape. Okay, go into control unit. We got engine, transmission, ABS, airbag, BCM, auto drive, intelligent key. Now obviously it doesn't have a lot of these modules. Alright, let's have a look. We gotta find, it must be this one, all-wheel drive, four-wheel drive. I was just in that module. So I'm going to write these codes down. Maybe all these problems are related to the speed sensor issues. Read codes. So we got a P1820, a U1000, and a P1808. Vehicle speed signal, ABS. So we can look at live data, ECU inputs, all signals. I'm sure that that module wasn't listed on the Snap-on scanner, but I'm going to look again in a minute. And we're going to set this up on a hoist and have a look at the wiring, obviously, to see if we can see anything obviously wrong before we get too dramatic here. Alright, let's do a visual here. I see the wires have been repaired on the top of that speed sensor up here. Somebody's done some repairs to the wiring, so that's sketchy because it does have a code for the left front speed sensor or circuit. Now it could be that the speed sensor has failed. Looks like it might be part of the wheel bearing, or at least it's inside the hub there. And at the back here, he said he had a wheel bearing replaced back here. It looks like this side has been apart. The speed sensor looks intact, but it could be damaged. Wiring looks okay up there. I see a brake line is seeping here on the rear axle housing. So rusted. So it's going to need a brake line replaced. In fact, the other one isn't much better either. I wonder what kind of speed sensors they are. They're probably digital. And the wiring harness goes up. Looks like it's an assembly, or the connector is way the hell up on top of the gas tank or some stupid thing. They couldn't have a connector at the speed sensor or somewhere in the harness here, could they? Oh well. That's why I get all the fun jobs, I guess, some days. Looks like the axle seal's seeping a little bit here too. Well, gotta find out what kind of speed sensors these are. So here's the information regarding the ABS speed sensors. I was right, according to this. They are digital. Generate a digital signal sent to the ABS ECU to determine wheel speed. Signal frequency increases with vehicle speed. Metal debris and loose sensors can cause erratic signals. Harness is easily damaged during brake service. Okay. So, signature test. And it's a digital signal. I'm going to look in all data and see what it suggests for those two codes. It has a 1108 and 1104, both for the left front, and 1102 for the left rear. I'm also going to look up that P1564. So I decided I'd check out what C1102's troubleshooting chart is. Disconnect the ABS actuator and the electric control unit connector E125 and the wheel sensor malfunction code. Check the terminals for deformation, disconnection, looseness damage. No good, replace, go to 2. Check wheel speed sensor output signal. Connect ABS active wheel sensor tester J45741 to the wheel sensor using the appropriate adapter. Well, I'll just get right on that tester then. The green power indicator should illuminate. If the power indicator does not illuminate, replace the battery in the ABS active wheel speed sensor tester before proceeding. So they have a signal generator or a specific tester that they use for these. Well, that's not, this chart is going to be useless to us because I obviously don't have that. And I'm sure that if I go to 1108, 1102, although it looks like the wiring is compromised. Yep. J15 or 45741. So we can't do that. So we're going to have to, while I'm here, I'm going to look up that P code, P1564. (1564). Steering switch has a variant value of electrical resistance for each button. Oh, this is for cruise control or something. Yeah, that's cruise control. Why can't you just say cruise control? Automatic speed control, I don't know what D stands for. Okay, so that's related to the cruise. So you might have a clock spring problem, or the switch pads might be defective. Okay, well that's minor. We're not going to worry about that right now. And of course the U1000 code. It's just a generic code for a failure in the data transmission between modules. So you're kind of on your own. I call them U codes for ugly codes because they can be a real pain in the ass to diagnose. We're not going to overly complicate things for now. We're going to stick with the simple things like the wheel speed sensors, even though that's not so simple. I think I'll check for case histories and TSBs. So here's the C1102 code in Identifix. Comes up with a couple of cases and a TSB. Let's see the TSB first. Wheel speed sensor diagnosis. Updated wheel speed sensor diagnosis. Bulletin released to assist in accurate wheel speed sensor diagnosis. Consult 3 plus and or the wheel sensor tester essential tool J45741 is recommended. Did the wheel speed sensor DTC reset? Yes. Which DC reset? 1102. Yes. Follow the diagnostics on page 3. Check the wheel speed sensor output signal. You know what? This is useless because I don't have that tool. So let's go back to the cases that I saw here. Here's a case. Light is on, has a left rear speed sensor signal code. Replace the left and right rear wheel speed sensors and the code returns. Scan data shows 0 miles per hour for the left rear wheel speed sensor. Now they changed the wheel bearing. I wonder how this wheel bearing is designed. I wonder if there's a reluctor in there and it's got to be pressed on to the right dimension like a Toyota. Because he said the problem occurred after or shortly after replacing the axle wheel bearing back there. Check for reference voltage on the blue wire from the anti-lock brake system actuator and electric control unit with the ignition switch on. Blue wire should have approximately 10 to 11 volts, 10.5 to 11.5. Some vehicles, when the wheel speed sensor is unplugged, the control unit takes the reference voltage away. So if there is no voltage on the blue wire, unplug the right rear and check for reference voltage on the green-yellow wire to that sensor with the ignition on. If there's reference voltage on the green-yellow wire at the right rear wheel speed, but no voltage on the blue wire at the left rear, back probe and check for reference voltage on the blue wire at terminal 36 of the ABS actuator. Well, that makes sense. Well, first of all, I got to find that connector and see if there's anything obviously wrong with it. I think the front one is damaged wiring. I'm going to look closer at that, but I'm pretty sure the wiring is damaged, and I don't know if it's repairable. Usually trying to repair those wires where they flex is just going to fail again repeatedly. Not a lot of cases on this. It might be that this is, well, definitely not a mainstream vehicle. There's not a lot of these around Thunder Bay. In fact, this is the first one I'm actually working on ever. So I'm kind of learning as we go here, together with you guys. So here is the left rear speed sensor signal wire, and it goes up above the frame up here, and there is a connector in there attached to the frame rail above the charcoal canister, right back in here. That's really convenient. Thank you, Nissan. Otherwise it's a molded wire all the way, and that's the only place you could actually test it, would be at that connector. And as you can tell, this is a bit rusty. I don't think this canister and the bolts go from the top down. Ay, ay, ay. Well, I'm gonna have to see if I can fish that connector out somehow. But I just noticed something minor on this side here. This vent is obviously rusted solid, so that could contribute to unwanted pressure in the differential and cause the seals to leak, but that's not differential fluid, that's brake fluid leaking from that rusty brake line. As I said, there may be a speed sensor reluctor in here that was tampered with, removed, moved, something. I'm not sure how it's actually designed. I'm going to have to look at an exploded diagram of this and maybe talk to the customer. So here's an exploded view of the rear axle shaft. This is the procedure to replace the axle bearing. So it's got a bearing on the axle shaft, kind of like an old Ford design. You use a slide hammer to pull the bearing and axle shaft assembly out. Oops. There's a picture of it. So there's the speed sensor reluctor. Now, if the axle bearing failed, it's possible it could have damaged the speed sensor because the pressure of the movement in the bearing could have allowed contact between the speed sensor and the reluctor. It doesn't look like the reluctor's out here like a Toyota, so it shouldn't have had to been removed. So it's a pressed on wheel bearing, held on there with a bearing retainer. Yeah. And I don't think we're going to be able to get the wheel speed sensor out of the axle housing without it failing. So I removed the left rear wheel, and I took a chance to see if that speed sensor would come out, and lo and behold, it did. Engineers actually designed it well. They've only got little ribs instead of a full circle and an O-ring like most engineers. But if I flip the sensor over and look at the bottom of it, it is physically damaged. I would imagine when the wheel bearing failed, there was enough play in the bearing to allow the speed sensor reluctor to contact the speed sensor and damage it. The tip of the sensor is broken. You can see the metal piece there. So it's going to need a speed sensor for this one for sure. Fortunately, it's coming out. I'm going to look in there and see what the speed sensor reluctor looks like. See borescope. So I've got the snap-on borescope set up here to look at the speed sensor reluctor, and I went through and turned it around and turned the axle shaft, and all the reluctor teeth look fine. So we're going to call this speed sensor, and hopefully that's going to fix the left rear problem. Now for the left front problem. So after removing some tape and loom, this is what I find here. The wheel speed sensor wires to the left front have been repaired previously. They don't look like they're failed, but who knows for sure. So I'm going to price a wheel speed sensor. Maybe it's not too much money, because fixing these wires, mind you, this is an area where it doesn't really flex. It flexes here, but this could be secure. It won't move. But still, trying to repair this wire is often doesn't last because of the harsh environment. Oh well, we'll find out what a sensor's worth. So here's some aftermarket parts information. The front speed sensors are the same, right and left. Let's see what they look like. So it's serviceable. I wonder if it actually comes with the wheel bearing. I'm going to check a wheel bearing and see, because the sensor alone, the sensor alone retails for $300. Mind you, that's Canadian dollars. The left rear sensor is cheap, 85 bucks. But do they have one anywhere? Rear left. Let's see if there's any stock anywhere. Survey says oh yeah, they're available. Edmonton, 3 days away. Well, we're going to go ahead and order one of those up right off the bat, because that's a reasonable price for a speed sensor, 85 bucks retail. Let's put one of those in the cart. The rear left, add to the cart. Now the left front, on the other hand, let's check a wheel bearing. Let's put it in the cart now, just one. And then we'll check a wheel bearing, in case it's serviced with a wheel bearing. Oops. Yeah. Helps if you spell it right. Front ABS speed sensor, front wheel bearing and hub assembly. Let's see how that's serviced. Sometimes the bearing's just a few dollars more. Look at that. I've had bad luck trying to take the speed sensor out, and if it's ever been changed before and it's got a off-brand wheel bearing in there, sometimes the speed sensor doesn't fit. So this is a complete wheel bearing for 430 bucks. Here's one for $200, and it comes with the speed sensor. Let's see what it looks like. Yeah, it does come with it. So it's like a small block, or it's like a old 90s Chevy with the 3 bolts to hold it in. Very similar. It's hard to justify spending $300 for the wheel speed sensor when you can buy the whole wheel bearing assembly for $210. Look at the Dorman one, it's $182. So you really got to check before you just jump in and buy the sensor, because God knows we'll try to get the sensor out of the wheel bearing and it'll break, and then the piece will be in there, and then you'll contaminate it. And so I'm going to talk to the customer and see if he wants to go with a premium quality SKF bearing or a mid-grade quality World Parts bearing. I got a feeling he's going to say the World Parts bearing. And although these ones are actually in stock, I'll talk it over with him. So we'll stop at that point. That's it for now. That's enough for tonight. So I decided to investigate why the red brake warning light is on, thinking that it might have something to do with multiple faults in the ABS. But looking at the red brake warning light, it supplied power from this circuit here. It appears to be an LED. It has a low brake fluid level switch, and the brake fluid is full, and a parking brake switch, and looks like some kind of a bulb check circuit. I don't know why it ties into the alternator over here, or the generator, alternator, whatever. So we're going to double check. It doesn't show that the brake warning light is potentially controlled, well, unless it's got something to do with this unified meter control unit. And in the ABS data, it doesn't tell me that it wants the red brake warning light on. It says it wants the slip light on and the ABS light on, but doesn't mention the red brake warning light. So I'm thinking that there could be a problem with the park brake switch. We're going to have a look at that. So I disconnected the brake fluid level switch, It's just a simple switch that's normally open and closes with low brake fluid, so disconnecting it would simulate a normal level. And the brake warning light is still on. I looked at the park brake switch, which just is a little grounding switch on the side of the park brake pedal, and it appears to be working okay. So the next thing we got to figure out is, why does it go to the alternator, which unfortunately is down under the right front of the engine now that I got it back on the floor. So we're going to have a closer look at the alternator and disconnect the alternator. I don't know why that wire goes to the alternator. So as I mentioned earlier, I've disconnected the brake fluid level and I've disconnected the park brake switch. Both are just simply grounding the circuit theoretically, and the warning light is still on. Unless there's something else in the combination meter that is capable of turning it on. I don't imagine they'd have a theory of operation in the service literature here. So here's a case on Identifix stating the ABS light, red brake warning light are on. Of course, our ABS lights are on because of the wheel speed sensors. Service engine soon light is on as well. Speedometer is inoperative. I think this customer actually said the speedo stopped working but then started again. I'll have to double check with that. Has a vehicle speed sensor code P0500 in the engine ECM. Well, we don't have that. And we do have communication with the ABS actuator. You know what? I'm not going to spend any more time chasing this brake light warning light until we fix the wheel speed sensors. And when I get it up on the hoist next time, I will look at the wiring going to the alternator and try and find out how that circuit works. And then we also have the airbag warning problem that I'm not sure you wanted me to look into or not.